Okay, so we're going to talk about the basic rules for integration. Um, so the most basic rule says that, well, if n is a rational number, so if it can be expressed as the quotient of two numbers, so anything relatively normal, um, and n does not equal -1. Now, we'll explain why this is the case later, but if you think about this intuitively a little bit, you'll find out what's going on. It says that if you integrate x to the n power bx, that what you're going to get is you're going to have to raise x one more power, so you're raising it to the n plus 1, and then you divide that by n plus 1. You divide by that very same new exponent. And then also you have to add the constant term c, um, where c is a constant. We talked about this in class. The reason why you have to add c is that when you go in reverse and you take the derivative of this, the c becomes 0. So because it is invisible in this form, we have to say that it could exist, and that's why we add the c in. Now, this rule is very basic rule. It's kind of like the reverse power rule of, and we use this for integration. Um, Now, there are a few other rules as far as how you can deal with integrals, and they're fairly intuitive. Um, One of them is called the constant multiple rule, which says that if we have some constant k that's being multiplied by a function, so like we're taking the integral of k times something, then what we can do, excuse me, I forgot my dx. What we can do is we can actually take the k, the constant, and take it out of the integral and just multiply the integral of f of x by that k at the end. So it just kind of saves us a little time um, if we need to. Like any constant, so like if you had, real quick, if you had like the integral of 5x, that's the same thing as 5 times the integral of x. Okay? Regardless, the 5 will be involved either way. It's just sometimes it makes more sense to move it to the outside to make things less confusing. Next rule is the sum rule. It says that if we take the integral of two functions added or subtracted together, that what we're going to get is each individual function added or subtracted from each other after being integrated. So we can split things up. So, just quick example of that. Like if you had the integral of, 5 minus x, that's the same thing as the integral of 5 minus the integral of x. Not that that is what you necessarily want to do, but the idea is that you can do that, and it makes things easier to work with oftentimes. Now there is one other thing that, and we've worked with this in the last day. If you do have something maybe a little more complicated, so let's say we have, ax plus b. So kind of like just some sort of line, some sort of basic function to the n power. Now, what ends up happening here is that just like in the power rule, okay, you're going to end up with the same part. You're going to have your ax plus b. You have to raise that to the n plus 1 power because we're adding 1. and then we divide by n plus 1 as well. Now, the only difference is that because we now have some sort of multiplier acting on x, we have to account for that too. So imagine this. When we take the derivative of ax, or of anything times x, we end up with whatever that coefficient is. And when we go backwards, we do the reverse. We have to divide. So in this case, because when we go forward, we multiply by n plus 1, and that's what we're dividing here. When we go forward from ax plus b, we multiply by a. So we have to also divide by a. So as part of this is kind of the beginning of what we will notice as the reverse chain rule, and that you have to undo everything that had been done before to find your derivative.